Today we're going to talk about compound inequalities. Compound inequalities can be either conjunctions or disjunctions. Conjunctions, if you think about from English, we use the word and it's where we join them together. Disjunctions, on the other hand, are where we're going to separate them and have two separate graphs, the word or. For instance, a conjunction, you can have a Snickers and a Twix, meaning you can have both. Disjunction, you can have a Snickers or a Twix, meaning you have two choices, but you can choose one. Let's take a look then at an example. 3 is less than 3x minus 6, which is less than 8. To begin solving, we take this middle section and we're going to use it like our normal equation. So I've got to get x by itself in that middle. To do that, I have to add 6. When I add 6 there, I add 6 to all sides because, again, I'm trying to keep it equal and balanced, just like solving an inequality. So that gives me 3 plus 6 is 9, is less than 3x, which is less than 14. Then I divide all parts by 3. Therefore, 3 is less than x, which is less than 14 over 3, becomes 4 2/3. So what this means is that I have an answer, a solution, that is between 3 and 4 2/3. So when I make my graph, I make my number line. I'm going to put the 3 on the line, and I'm going to put 4 2/3 on the line. They are both going to be opened dots because of the symbols. And I'm going to shade in between. Notice my x is in between those two. This is a conjunction, meaning it's an and. It's between those two. This one happens to be another conjunction because the variable is in between the two inequalities. I'm going to solve it the normal way. First thing I'm going to do is I'm going to distribute. So that's 2x plus 4 minus 7, less than or equal to 13 on the right, and greater than 3 on the left. Then I'm going to combine like terms. So that's 2x minus 3 in the middle, bringing everything else down. Now I'm going to add 3 to both sides. 3 cancels in the middle. 3 plus 3 is 6. Which is less than 2x, which is less than or equal to 13 plus 3 is 16. Divide everything through by 2. So 6 divided by 2 is 3, which is less than x, which is less than or equal to 8. So my answer is going to be between 3 and 8. I'm going to add 3 and 8 onto my number line. The 3 is going to be an open dot, while the 8 is going to be a closed dot, shade in between. And since x is in between, it's going to be everything in between 3 and 8. 3 is not a solution because it's an open dot. However, 8 can be a solution because it's a closed dot. Let's take a look at one more example. An example of an or statement. This is a disjunction, meaning my graphs are going to go two separate ways. I'm going to go one equation at a time. So I'm going to take this first one, or inequality, and I'm going to solve it. Add 3 to both sides. That becomes 2x is less than 10. Divide by 2. So x is less than 5. On the right-hand side, I'm going to solve this one. Add 4 to both sides. So 4x is greater than 24. Divide by 4. So x is greater than 6. So now on my number line, I'm going to graph it. I'm going to have 5 and I'm going to have 6. 5 is going to be an open dot, and it's less than, which means shade to the left. 6 is going to also be an open dot, but it's greater than, which means shade to the right. So my solution is either here or here.